All right, in the last video, we just finished up graphing over here this negative cosecant 2x plus 5, and now we just need to answer the questions about the characteristics of the graph. So my domain of the graph typically for cosecant is going to be negative infinity to infinity, except wherever I have my asymptotes. And I can very clearly see right now that this is what I've got here is it's going to go ahead and be from 0 to pi instead of from 0 to 2 pi. And my asymptotes are now every half pi instead of every whole pi, like it previously was when I did cosecant up here, where it was every pi instead of every half pi. Well, because we went ahead and changed the period of our graph, that changed where our asymptotes are. So the easiest way to go ahead and figure out what the domain is going to be and what those restrictions are going to be is, let's go ahead and say we'll have our domain as negative infinity to infinity. Except what I'm going to do is I'm going to find my very first asymptote, which here is pi over 2. So I'm going to say, okay, x cannot equal pi over 2 plus, and whatever I'm going to add here is whatever half of my period is. Well, here, my period, if I go ahead and I go from 0 to pi, so my period is pi, so it's going to be plus pi over 2. Okay. And then that's, again, where k is an integer. Now, the reason for this is because if I go ahead and I look at my graph, if I'm going from 0 to pi, and then if I'm going from 0 to pi right here, and I have a asymptote every half of my period. So I start here at the beginning, halfway through, and then at the end of the period, and then it's going to cycle again. It's basically saying that it's going to be every half of my period that I'm going to put here. So the pattern that you're going to always do for your domain when you're creating the x values that it cannot be, and same thing for what your asymptotes actually equal. So here it would be x equals pi over 2 plus pi over 2k, where k is an integer. What you're gonna always put here is whatever half of the period is. So let's write this aside. All asymptotes. So you would do x equals first one and then you would go plus half period. Okay, that's what you have. So that's what you're going to go ahead and do each time. All right, range. So range is going to go ahead and be from negative infinity, and the lowest point that I have labeled on my y-axis is 4. And it's going to include that union from 6 to infinity, because that's my highest point that I have labeled. All right, so that goes ahead, that gets me through this problem right here that has this period change, vertical reflection, and a vertical shift. Let's try this problem here. This one is going to have what going on with it? Well, this 1/2 right here, that is a b value, so that's going to change the period of my function. And then this pi over 3 is going to be a horizontal shift, so it's a phase shift. So I've shifted my graph actually, and this pi over 3 here, since it's being added, tells me I've actually shifted my graph left pi over 3. So again, everything that's on the inside of the function affects which values of my table. The x values, everything on the outside is going to be those y values. So I'm going to take this and I'm going to treat this as if it's cosine. And so let's go ahead and create my table of values that I would have created. This is what I would have if it was cosine. And then let's go ahead and apply these transformations that we have for this. All right, so with these transformations, this 1/2, what that's going to do is, remember, I do the opposite of what I see. So I'm going to be multiplying by 2. So that's going to be taking all of my x values, and I'm going to change the color. I'm going to multiply by 2 times my x values. And then this pi over 3, instead of adding pi over 3, I'm going to subtract pi over 3. So that's what I'm going to do with all my x values. So I'm going to go ahead, I'm going to take all of these x values and multiply them by 2 and subtract pi over 3. So if I do 2 times 0, you know what, I'm going to do this in 2 separate steps because I know the majority of you probably are going to kind of get lost on some of this. So let's do 2x first. So if I do 2 times x, I get 0. And then if I do 2 times pi over 2, that's going to give me pi. 2 times pi is 2 pi. 2 times 3 pi over 2 is going to get me 3 pi. And 2 times 2 pi is 4 pi. Okay, so that's just taking this b value. All I did was just do my vertical, my horizontal stretch by a factor of 2. And then what I'm going to do now is I'm going to go ahead and I'm going to apply that horizontal shift, which that's going to be taking my x values and I'm going to subtract pi over 3. So now I'm going to take all of these x values that I just had right here and I'm going to subtract pi over 3. So if I do that, for example, I'm going to do 0 minus pi over 3. If I was doing this by hand, I'd have to get a common denominator. Fortunately for you guys have calculators that you can go ahead and use, and it just makes everything easier. Obviously, 0 minus pi over 3 is really easy and gets you negative pi over 3. But I know how a lot of us get when it's talking about fractions and subtracting and adding things. So again, if I did this, it'd be pi minus pi over 3. Well, that's 3 pi over 3 minus pi over 3. So that's 2 pi over 3. And then if I did 2 pi minus pi over 3, so let's do 2 pi minus pi over 3. Again, multiply by 3, top and bottom. That would get me 6 pi minus pi, so that would be 5 pi over 3. If I did 3 pi, so 3 pi minus pi over 3. So then again, put this over 3, multiply by 3. So I have 9 pi over 3 minus pi over 3. So that's going to get me 8 pi over 3. If you haven't noticed, right here, if I'm going between each one of these, how far apart are each one of these? I'm just adding by 3 pi over 3 each time. So negative 1/3 plus 3. So if I go negative 1 plus 3, that gets me 2. Plus 3, 5. Plus 3, 8. Okay, what's 8 plus 3? That's 11 pi over 3. And that's exactly where this would end, is at 11 pi over 3. So let's try that. So what I'm going to go ahead and do now is I'm going to go ahead and I'm going to label my x-axis. But if you notice, I'm starting here at negative pi over 3. And I'm going to go to 2 pi over 3, 5 pi over 3, 11 pi over 3. Oh, sorry, I skipped 8 pi. I got ahead of myself. 8 pi over 3 and 11 pi. And then we didn't do anything to our y values. I don't have an a. I mean, I have an a, it's 1. So my amplitude is 1. And I don't have a vertical shift. It's 0 that's being added there at the end. So this just goes up to 1 and down to negative 1. And so what I would go ahead and do is I'd recognize that this is cosine, and I'm going to go ahead and plot each one of these points. Negative pi over 3, 1. So negative pi over 3, I'm going to go to 1. At 2 pi over 3, I'm at 0. 5 pi over 3, negative 1. 8 pi over 3, 0. 11 pi over 3, up at 1. And here's that little ghost graph that I would have. And I'm going to draw those vertical asymptotes straight through everywhere where this cosine graph touches the midline. And then I'm going to go ahead and invert that. And that's where I get my graph. Okay. So what is my domain of the graph? In fact, before I do domain, let me find my period of my asymptotes. That might make it a little bit easier to find my domain. So my period of this, it's 2 pi over b. So 2 pi over b. What's my b here? b is 1/2. So I have 2 pi divided by 1/2. When I do keep change flip, that gets me 4 pi. So that's my period. So my asymptotes. Asymptotes are going to be x equals, what's my first asymptote? 2 pi over 3. And then I'm going to add half of my period. Well, my period is 4 pi, so I'm going to add 2 pi k, where k is an integer. And then my domain is going to be from negative infinity to infinity, except x cannot equal 2 pi over 3 plus 2 pi k, where k is an integer. And then my range is going to be from negative infinity to negative 1, union 1 to infinity. That's it. So like I said, basically what you're going to do every single time is you're just going to go ahead and graph its reciprocal function. Remember, secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. Sorry, forgot what I was saying. So that's basically all you're going to do is you're going to go ahead and just graph its original function, and then just everywhere where it crosses the midline is an asymptote, and then you're going to invert your graph. Hopefully this makes sense, but we'll work on it when we get back to school.